Okay, good morning, guys. Here's a very little tips about learning SolidWorks simulation. I'll show you how to simulate in SolidWorks. For example, for us, for mechanical engineering or aerospace engineering, we like to see the stuff we designed and how it will react when it will be in real-time situation. So, for example, this is a simple structure. For example, it will be used in any mechanical part, so we're going to see whether it will break or what kind of effect it will give when it will be in real-time situation, and that is why simulation is used. And we normally use FEM based simulation, that is called finite element analysis based simulation. If you're in third year or second year student in mechanical or space engineering, probably you have some ideas about FEM. So let's get started. First of all, what you have to do, you have to have solid part built in any 3D software. Here I have built a beam and a column. And the next part is you have to start simulation. And by default, you don't see any simulation tab here. For that, you have to right click here in this bar, and you can see simulation. Just click it, and you have a new tab here called simulation. To start a simulation, first of all, you have to do go to Study Advisor. Click the drop down menu on new study, and it will pop up with whole new stuff. There are a lot of options here: static, thermal, frequency, bucking. Actually, SolidWorks is quite good for CFD, computational fluid dynamics. Because you are amateur, I'll try to show with static load. So click static and click OK. Okay, here you can see a new stuff here, and there's all these grayed out buttons are visible now. So there are some steps you gotta follow, and SolidWorks has put them in really nice order. First of all, you have to apply material in real life. What kind of material you're gonna use for your part, and secondly, you have to fix fixtures, advisors. For example, you have nuts and bolts or some other things you're gonna fix with your component. For example, you have attached this one with welds or maybe a nuts or something, or maybe a groove. So you can simulate that stuff with in real-time situation. And before doing simulation, you have to fix this part with something else. This is called fixtures. They have fixtures advisor, fixtures gallery, roller slider, fixed hinge. You know hinge, right? It's in door, elastic support. It could be a spring or something. Advanced fixture. And third thing, you have to do external load. You have to put a load on your geometry. Actually, you have to do a hand calculation or by software calculation how much load is being applied in this material, and in which direction you're going to apply that load. So there are different kind of loads here: external loads, advisor, force, torque, pressure, gravity, centrifugal force. Probably you know all of this, so we'll try with normal force. The next thing you have to do is the connection. You have to connect this with bolts on something else, what I told you. Then you have to do run. You have to create mesh, and then run the whole simulation. Mesh is kind of like polyhedral structure of a solid. It makes a cubic structure, not cubic actually, triangular structure of your very little structure, millions of structure in your part, so that it calculates only small part of that area, and at the end it integrate all the results. And this is called a finite element analysis. So okay, let's get started. For applying material, you have to go here in this icon, click right button, edit material, and here the list of all materials you have. So SolidWorks material, and go to I like copper alloys because of the colors, and I'm taking brass from here. Click apply, close, and the next thing you can see material is brass now. Next thing you have to do connection. I'm not gonna do it here. You can do it by yourself. The fixture, how your part is fixed with another part. So click right button or go from here, picture fixed geometry, I'm going to fix this part here with button, with ground maybe, and you can see other options: ruler, slider, fixed hinge. And this is a simulation how this side is fixed and how this side is moving with respect to this side. Click OK, and next thing I have to do, apply force. So we're gonna put here force, and you have to click a face here. I'm clicking this face. Okay, and it could be like SI, English, or metric. I'm choosing SI, and I'm putting 1000 Newton. Click OK and click OK. The next thing you have to do, create mesh. Let's create mesh. Here the default, if you put this slider all the way right side, it will create more mesh, and your computer will have to calculate a lot of stuff. So it's okay to put it in the middle, in a default place. So it's creating mesh. You can see, as I said, these are all triangular shapes. It has been divided into triangular shapes everywhere, thousands of. You can see my computer has become a little bit slow. And the next thing you have to do, run the whole program. Let's run it. So it might take a little bit of time. Okay, here's our result. Look at this, how beautiful is it? And if you're a student of mechanical engineering or aerospace engineering, you'll be astonished seeing this result. Here, red colors means the part is in tension, and the bluest color means it's in compression. So you can see this part will be compressed here, and this part, and in the bottom a little bit will be compressed. Will be in tension. So this is that's it for today, I think. And here you have got 3 results by default: stress, displacement, and strain. Just so to see the other results, just double click it, and this is the result for displacement now, and click strain, and this is the result for strain. If you're a student of mechanical engineering, probably you have some ideas about this. And and if you see the simulation, click on straight right click and click animate, and you can see how your part is gonna react when you put pressure on it or put force on it. You can save this as AVI file from here, these options, so that you can share it with your friends, or you can use it in your presentation. So here it could be like pause, stop. Sorry, right error. It's okay. I'll show you in next video.